Sustainability is a topic which applies to all levels of tall building development and design, from the choices of the materials used in the building to the larger urban scheme in which it is built. This session sought to take a closer look at both the macro and micro levels of sustainable decision-making. The mayor of Chicago, Richard M. Daley, presented on the bigger picture and described some of the actions the city of Chicago has taken to promote green development.
The question was raised about whether sustainability and green design are just some kind of a trophy thing. I can tell you that in Chicago, green buildings don't represent a trophy. They are essential part of our environmental efforts that save energy and money. As we rehab existing city buildings and construct new ones, we follow green building policies. Our Center for Green Technology, we rehab the former industrial site on the west side of Chicago, one of the first municipal buildings in the world to be awarded a platinum rating by the U.S. Green Building Council. Our Green Home program is for builders and developers who are constructing new residential units in Chicago or renovating existing units. It gives points to builders for every sustainable technique and material used in the construction of a new home or residential building, can qualify the projects for expedited building permits. There is a sustainable development policy which places green building requirements on any project that receives city funds, bonds, or tax breaks. Our Green Roof Improvement Program provided matching grants to construct green roofs on existing buildings in the central area, the downtown area of Chicago.
Mayor Daley went on to describe the city's policies that encourage green roofs. And in a move to lead by example, he described the greening of the roof on City Hall, completed in the year 2000.
Of course, Chicago is a leader among cities in the use of green roofs. We now have 600 green roofs, completed or underway, totaling more than 7 million square feet. We have aggressively pursuing green infrastructure throughout the city to keep clean stormwater out of the sewers and reduce the urban heat island impact. Since I became mayor, we have planted over 600,000 trees, landscaped more than 90 miles of medians on our major streets.
The mayor also advocated that tall buildings play a key role in the creation of desirable urban environments.
People want to live in a metropolitan area because they offer more opportunities, more choices, and of course, more people. They also want open space. They want nice parks, clean beaches, jogging paths, bike trails, flowers, trees, grass. They want clean and pure water. Our goal is to ensure that tall buildings complement these desires and improve the quality of life for everyone in Chicago, not just for the people who live or work in them.
Russell Huffer of Viricon talked about the curtain walls of tall buildings and how the choice in glass systems can make a significant impact on the building's energy efficiency.
The thing that I'd like to talk about in terms of glass and aluminum, and certainly we've heard about other products, metal products that could be used in commercial buildings, but they really are the most economical environmental filters.
He also argued that building integrated photovoltaics are not cost-effective and provide little energy. A far greater impact can be made with effectively using the facade to draw light into the building and reduce the building's lighting demands.
We are far better off in designing our buildings of the future to harvest light and to bring the light to the interiors in its natural form. And in doing so, it's been clear that some of the leading studies have indicated we only need to harvest about 5% of the incidental light that comes from the sun to bring it to the interiors to have an effect, a meaningful effect, and to reduce the energy required to light buildings. And in doing so, that it really, the use of interior light shelves, when we're talking about this energy, remember only half of this energy is light and half is infrared. So you have 50 watts of light striking this. If we can redirect some portion of that and dim these, we've done a major job in reducing the energy consumption of commercial buildings.
Guy Turner's presentation looked at a new material that has been developed called SPS Floors, standing for Sandwich Plate System.
The way we make SPS is to take two steel plates and inject a liquid between them. The liquid cures and glues to both paste plates, so there's no adhesive between the three layers.
Guy explained that the SPS system is significantly lighter than concrete and has been proven through its use in the shipbuilding industry. He described the challenges in introducing a new technology into the building construction industry, but explained the potential benefits that could be seen if it is adopted for high-rise applications.
Similar time, we asked Arab to have a look with Gardner and Theobald at a generic 44-story building to try and get a grasp on what could be done with this technology. 44 floors, classic steel, square frame, concrete core, 9x9 grid, very simple, very generic. The outcome was 37% lighter overall structure, 3.7% shorter building, 14% faster to build, 100-week program, 22 weeks earlier start of fit-out. I got to the end of it, writing the report, and I won't name him, but somebody reasonably senior in Arab said, and yes, you've got an extra floor out of that. Big prizes in height-restricted locations such as London and New York. Then with Arabin out of New York, we started looking at this building with Benjamin Romano in Mexico, just to see the effect that SPS might have on a building like this. It's a 57-story building planned for Mexico City. Test piles are finished. There are no columns. There's a diagrid on the outside. There's 2 shear walls, leaving a triangular finish on the facade, overlooking the main central park of Mexico City. The outcome was 25% lighter floor trusses, lighter and thinner shear walls, concrete shear walls, fewer piles, and a 15% faster build.
Do you see a future in which Chicago would be, again, a world leader with the world's tallest building?
Oh, I hope so, sure. I'm always looking for developers and architects and all those who, and the financing for taller buildings, yes. I think it's important for us. It really enhances the skyline. It shows that we're willing to challenge our city, and especially taller skyscrapers, yes, I'm 100% for it.
From your experience, when a new project comes in, a big new project, hotel or office, to what extent does it actually bring in new business versus just sort of take business from older existing projects?
No, it doesn't. Like in the downtown area, we have found out a lot of the historical buildings, they've lost tenants, commercial tenants, most all of them have. And so how do you protect them for the future? So we enacted a TIF, tax increment financing district, for buildings all the way through almost to the 70s, to be very frank. And an example is the Willis Tower, the formerly Sears Tower, that we put a TIF district on, and they're retrofitting their heating, air conditioning, and other things. And we put about $85 million into that. We're looking at all the buildings downtown so we can create TIF districts so they can restore and rebuild their air conditioning, heating, windows, and so they can take commercial tenants or residential buildings, turn them to residential buildings. Otherwise, they're going to be vacant. There will be no use at all. And that's what we're looking at. We have to be able to preserve these, at the same time help the owner of the building to retrofit these buildings according to the new environmental standards that everybody wants, any type of tenant you get in these buildings.
Ross, would you give us some insight into your future research, into research that's happening now for future products in your line of business?
We use nanotechnology today to create thin films that provide filters to undesired and desired energy transfer through glass. We're looking at some of the same kinds of technology to redirect light so that as the sun's light comes through a window and streams in and immediately goes to the floor where it turns into heat as soon as it strikes anything, can we use nanotechnology to bend that light and send it deeper into buildings? So that's one of the things that we're looking at.
How much steel is used to produce the SPS panel when comparing to reinforced concrete floor for the same floor loading?
More rebar. I don't know the exact numbers. It's never a question I've looked at. But if it is to do with sustainability, which may be the reason, what we've found is that we have more carbon content than a concrete floor per se, per unit, per nominal unit. Once we get to the bottom of a building, and accounted for the weight that we've taken out, we have a carbon saving or an energy saving or a total embedded material saving. For some reason, it's actually more in stadium, and I think that is a reflection that as the nature of the demanding nature of the structure goes up, then perhaps greater benefit comes through using lighter technologies.